to Fascinating Frontiers, episode 131, coming to you on July 14th, 2026. The universe has been busy. Let's get into it. 4 new NASA missions will help turn the moon into a permanent base, while another rover just ran a full marathon on Mars. NASA has selected 4 new projects that target habitats, power systems, and resource utilization to support multi-month surface operations. These missions build directly on Artemis program goals for crewed landings and gateway readiness. The selections move specific hardware into funded development phases. NASA will assign the projects to teams that must demonstrate key capabilities before full-scale deployment. The effort addresses open questions around landing cadence and long-term surface operations. Now we turn to the 4 selected missions in more detail. The projects target power, resource extraction, and habitat systems that must work reliably for months at a time. Success here would directly reduce risk for the first crewed landing and subsequent surface stays. The open question is which of the 4 will deliver flight hardware first, and how that timeline aligns with gateway module deliveries already in production. Artemis teams now have defined technology paths that address long-standing surface operations challenges. On a completely different note, the Perseverance rover has now driven the equivalent of a full 42-kilometer marathon across Jezero crater and surrounding terrain. Its instruments continue to collect rock and soil samples for eventual return to Earth. Mission teams use the distance milestone to refine navigation and energy management strategies for future traverses. This progress keeps the Mars sample return pathway on track by expanding the set of cached materials. Robotic exploration teams note that the accumulated traverse distance directly supports sample diversity goals established in prior mission reviews. From surface operations on Mars, we shift to a Lancer decision that keeps a heliophysics mission on schedule. The Sunrise mission will now ride a SpaceX Falcon Heavy instead of the originally planned Vulcan Centaur. Sunrise consists of 6 CubeSats that will form a radio interferometer to study solar radio bursts. The change keeps the project on schedule for its science objectives while NASA updates the exact launch timing. The spacecraft will operate in a near-Earth orbit to triangulate emissions from the Sun. This launcher adjustment maintains the mission timeline for mapping solar radio phenomena at multiple frequencies. Launcher swaps keep missions moving, so does remote software work on a spacecraft already 140 million kilometers away. Engineers completed 2 full reboots of the DART spacecraft with an 8-minute light time delay on commands. The upgrade prepares the probe for a close flyby of the asteroid it previously impacted. Data from the encounter will answer lingering questions about the exact outcome of the 2022 collision. The next observation window opens once the spacecraft reaches its new target geometry. Robotic exploration continues to extract new measurements from the spacecraft that altered Dimorphos's orbit. From controlled lab analogs, we turn to direct imaging of real stellar remnants close to home. Researchers at the CUNY Advanced Science Research Center built a radio frequency device whose properties vary in space and time to simulate a spinning body. The setup demonstrated wave amplification without any physical rotation of matter. This approach tests predictions about energy extraction near rotating black holes in a controlled environment. Further experiments will explore different modulation patterns to map the full range of amplification conditions. The laboratory result provides a new route for studying ergosphere physics without requiring astrophysical scale masses. If the Sun were compressed into a sphere the size of a city, its surface gravity would still be modest compared with a stellar mass black hole whose event horizon spans only tens of kilometers yet contains several times the Sun's mass. In the new experiment, researchers created a radio frequency structure whose electromagnetic properties change continuously in both space and time, reproducing the frame dragging effect that occurs outside a rotating black hole without any moving parts. Photons passing through the device experience an energy boost whose magnitude depends on the exact pattern of modulation, reaching amplification factors that match analytic predictions for orbits skimming the ergosphere. The setup operates at centimeter wavelengths and completes a full spatial temporal cycle in microseconds, allowing thousands of trials per second. The remaining puzzle is whether every detail of the energy extraction process scales exactly the same way when the rotation is produced by material motion instead of engineered modulation. Nearby stellar systems give way to an interstellar visitor carrying chemistry from another star. Astronomers at the University of Warwick and University of Colorado Boulder directly imaged 4 white dwarf binaries within 65 light-years for the first time. One pair contains the 9th closest white dwarf to the Sun. The discoveries relied on high-resolution imaging and radial velocity measurements to confirm the companions. Continued monitoring will reveal orbital periods and masses that refine models of binary evolution in the solar neighborhood. These nearby systems offer the first direct views of white dwarf binaries at distances small enough for detailed follow-up. Distant chemistry leads us back to Earth, where Arctic landscapes record ongoing climate-driven change. An interstellar comet passed near Earth on October 30, 2025, after ejection from its home system long ago. Spectroscopic analysis revealed abundance patterns that differ from solar system comets. Researchers traced the chemistry back to an aging star that lost the comet through gravitational scattering. Additional telescope time will search for more fragments or related objects on similar trajectories. The comet's composition offers a direct sample of material formed around a distant stellar system. From Earth's changing surface, we close with 2 special segments that zoom out to broader program and experimental horizons. Eroded material from ice-capped mountains on Russia's Severny Island spreads across a broad valley in striking fan shapes. The image captures how seasonal meltwater redistributes sediment in real time. NASA's Earth Observatory uses these observations to track changes in polar hydrology. Follow-up imagery will monitor how the fans evolve through the remaining summer season. The patterns provide a visible record of how warming temperatures alter sediment transport in high-latitude river systems. The Curiosity rover spent sols 4,941 to 4,947 approaching a geologic boundary between smooth, sandy terrain and rougher bedrock on Mount Sharp. Its cameras captured fine stripes and polygonal patterns in the transition zone. Science teams are using the data to understand how ancient water flows shape these layers. The next planning cycle will target specific bedrock targets for closer inspection. The observations add detail to the stratigraphic record Curiosity has built while ascending the slopes of Mount Sharp. Models show these planets could maintain atmospheres dense enough to turn surface rock into vapor that condenses into high-altitude clouds. The process would trap heat and sustain global magma oceans beneath. JWST transmission spectra of several targets already hint at the unusual chemistry required. Future observations will test whether specific absorption features match the predicted rock vapor signatures. This class of worlds expands the range of atmospheric compositions JWST can characterize in the sub-Neptune regime. Historical comparisons show launch prices per kilogram have dropped more steeply than equivalent freight costs during the steamship era. The trend reflects reusable booster performance and increasing flight cadence. Industry analysts expect the curve to continue as new vehicles enter service. The next data points will come from operational flights of next-generation vehicles later this year. Commercial spaceflight cost reductions directly affect the economics of constellation deployment and station resupply. Researchers flew instrumented vertical takeoff aircraft to measure motion and vibration levels that affect rider comfort. The study links specific ride qualities to willingness to use air taxi services for short urban trips. Results will guide vehicle design and flight path planning for the emerging industry. Follow-on work will expand the data set with passenger surveys during actual operations. The measurements provide quantitative guidance for operators seeking to increase public adoption of urban air mobility. The July 13 to 16 event focuses on new science opportunities opened by the Nancy Grace Roman Space Telescope. Sessions cover wide field surveys, exoplanet microlensing, and supernova cosmology. Participants include mission scientists and guest investigators preparing early data analysis plans. Outcomes will shape the first observing programs once the telescope reaches its operational orbit. Cosmology and astrophysics teams are using the workshop to align early Roman data with ongoing Hubble tension investigations. Government space spending across Europe reached approximately $15.4 billion in 2025, according to the European Space Agency report. Defense programs drove the increase even as global totals dipped 3%. The report details investment trends and competitiveness metrics for the coming year. Next year's edition will track whether the upward trajectory holds. The 12% growth reverses a broader global spending decline and highlights national security priorities within the European space sector. Before we go, keep an eye on the Soyuz S-29 launch scheduled for today that will carry a NASA astronaut and 2 cosmonauts to the International Space Station. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow, and if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. SpaceX Daily, the daily companion for following SpaceX as a public company, from Starship to the stock ticker. Find every show free at neuranetwork.com. Prefer reading? Today's full write-up, sources, and transcript are on the episode blog at neuranetwork.com. Same briefing, readable format. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.